Okay, hi everyone. So in this final tutorial, we're going to have a look at this last little folder I've got here called Rotation, Acceleration, Move Barbell. In this one, I'm not going to rebuild the whole network because it's got a few like little tricky moves that you don't necessarily need to do, but I think it's kind of fun to explain where we can go to start getting something that's a little bit closer to the movement that we're doing with our hand, even though the sensor doesn't actually have position in space, but we can do a few moves that start to infer that position in space. So if we go into this folder, I'm just going to walk you through one step at a time what we're looking at, and we'll come back to this in the workshop. So like everything, we've got our OSC in coming in here, and I'm laying down here we've got a select chop. So to do that, I would just be middle mouse clicking here and grabbing a SEL select. And here, in this select, I'm just grabbing linear acceleration. So here, we just grab our linear acceleration. Which one am I grabbing? Good point. I'm grabbing motion acceleration frame 2. So if I go here and I look down at our processed values, motion acceleration frame 2. Yeah, so that's what I've grabbed. And then I've filtered it, which we discussed in a previous presentation. If I turn off my filters here, everything will just be a lot jumpier and kind of look a little bit more abstract. The filtering just smooths out our signal a bit. I might actually turn the effect back up to 1. That should make it even smoother. Yeah. Oh yeah, I think that's much nicer having the effect of the filter at 1. So to add the filter, same again, you just filter, that's the next one in the series. And then we've got a math, and the math is just correcting our range. And this is something that you might play around with until you get to the position that you want it to be in. We're starting with an input on our acceleration that I just looked here at our range, and if I shake around, because we're looking at acceleration, between -1 and 1 seemed like a logical place to start. The values can obviously go a little bit higher than that, but -1 and 1 is fine. And by mapping it to minus 0.01 and 0.01, we're basically, you could say the same as we're dividing it by 1,000. Same. Then I'm also grabbing the this value of the accelerometer, raw3. It's the same one we've been using every time. It's basically when using the sensor tile, it's tilting it in the direction sort of parallel to the power supply. And then exactly as we did in the previous tutorial, I add a filter and I have the width at 0.5, effect at 1, and a math that's just mapping it, in this case, from -1,000 to 1,000. And as you can kind of predict, that's the rotation value that I'm doing here. Okay, so then this null here, this math is just bringing them both together. I've just connected them both to the same math. And then we are taking these, we're actually taking the values separately from these two maths here, and we're putting it into the transformation of a shape that I've built. And this shape, I'm working in SOP space, our surface operators, which are working in 3D. So we have a circle and a box. But the only reason I did that is so we can sort of see the difference between one end and another. If I make one of these circles larger, you'll see which is which. If I make this radius larger here, oh sorry, no, it will be the second transform where we're seeing which is which here. If I make one larger here, you'll see that that's the circle at the small end, and this is the circle at the base. And then I'm simply taking these shapes, moving them around, and then merging them into one final shape. So here's my box. I'm changing its position here. I'm taking this circle, you can think about it this way, I'm moving and scaling it here, and I'm moving and scaling it here. And again, you'll have this file so you can play around with it yourself. I'm taking the box, I'm moving it here, and then I'm merging them all into one shape. Then this transform is basically the movement of the shape, and then I'm doing the same thing. I'm making these viewer active, and I'm dragging things on. The only difference here is I'm doing a slightly different process, which if I make this viewer active here and I grab this, instead of saying export chop, I'm doing chop reference, and that's why it comes in blue. And the only reason I've done that is actually I'm making this into more of an expression than simply the one value. So if you look at what I've done up here, I've taken one value, which is like what I've done here, and then I'm just multiplying it by, another value. So if I go, well, I might have to type that in. Is that going to work if I drag that afterwards? I'm not sure if it's going to go into my... No, it doesn't work. Okay, yeah, so I've got to complete the expression myself. So what I'm going to do, if I took these and multiplied them by another, the first one is the one I dragged in, and you can see that they've got kind of a nomenclature or convention, which I can just follow. So I can say op, open brackets, close brackets, and then inside here, I've got the name, which this one will be math 7. The name is there, math 7, and then math 7, and then inside math 7, we're looking at the parameter, which would be whatever we've got in there, which has a slightly long name, which I believe it's the same, yeah, motion acceleration sensor frame 2, which is exactly what we've got up here. So if I type that in, 0/motion acceleration / sensor frame 2, then we'd also start getting this coming through our rotation. At the moment, that value seems to be 0, but if I start moving my tile, it would also start moving. So that's what I've done for my settings up here. The reason for that, if we go through what I've done in this transform chop, is the rotation one is very simple. So if I just go in here so we can see two things at once. If I take these off, if I delete this and delete this, I think it'll make a lot more sense. Sorry, let's press P. The rotation one's very simple, right? That's just, I've just exported that chop reference and I'm not doing anything to it. Whereas the other two, this is what's giving me that little bit of translation. And basically, I'm multiplying what we're getting from the accelerometer by what we're getting from the rotation. In this case, to invert the direction, I've said 1 minus that operator. In the second expression, I'm just rotating one value by another. If I go out of here, the result is that it was just a way of playing around so that it wasn't just rotation, and that the more I sort of actually change the speed of my gesture, we're using the accelerometer multiplied against the rotation. Sorry, we're using the linear acceleration, which is a calculated value, a processed value, multiplying it against the accelerometer data, which is just raw rotation value, to get something that kind of moves in space in a similar way to how I'm moving the device myself. Okay, so I've left that with all of those values in the file that we're supplying to you. This video is really just so you can watch it and have an idea of what it is. But in the workshop, depending on how we go for time, we can play around with this, add more things to it, change it out for other objects, or play around with different values. But because this one, it just has a little bit more complexity, I wanted to pre-record an explanation just so you've got it and you can understand the reasoning behind it. And then everything else here, the other thing that we haven't gone into, which is more of a TouchDesigner thing, is just this feedback that gives it that cool little fading effect. There's plenty of tutorials online about how feedback networks work in TouchDesigner. So I think they'll give a better explanation than I would. Okay, all right, so this was the final tutorial. I hope these have been somewhat informative, and I hope they make a positive complement to what we'll do together in the workshops. Okay, bye-bye.